Hello everyone, and then welcome to another video. So in this video we'll be treating three-phase circuits, okay, but we'll be solving questions, okay, right? So in case you are new to this channel, kindly subscribe, okay? Subscribe and then hit on the bell icon so that you don't miss out on any tutorial video, okay? Right, so let's dive right into this short video. So we have a question, okay? So we have to calculate what the current, the line current, power factor, power, and what the total volt amperes, okay? So we have what a balanced star connected load of what this impedance, okay? And then per phase, okay? So it means that we have what three phases, okay? So per phase is connected to a balanced three phase, okay? Keep that in mind, okay? We have what a balanced star connected load of this impedance per phase, okay? So it means that this is at three phases, okay? And then it's connected to a balanced three phase what 400 volts, okay, supply. And then we have to calculate what the line current, power factor, power, and what the volt ampere. So let's see how we go by that. So now we have what our impedance, okay, right? So this line circuit, okay, so we have what our solution, okay? So we have our impedance, let's say per phase, okay? Since it's per phase, we could just use certain notation, okay? We have this impedance, since it's what per line, okay? We are calculating per line, so we can just find what the magnitude of this impedance, okay? Right, so when you take the magnitude of the impedance, we have what 8 squared, okay, plus 6 squared, okay, and then we end up with what, when you do the calculation, you end up with what, something like a 10 ohm, okay, right? And then we have what 400 volts, okay? So we have what, again, similar notation, VPH, okay? So equal to what, the 400 volts, okay? It's in three phase, okay? So we have what 400, okay, divided by what root of 3, okay, and then that will give us what, when you compute this, you end up with what 231 volts, okay? Now let's proceed. So we have what the impedance and what the voltage. We have to calculate what the line current, okay? Now for star connections, okay, for star connections, we know that this will give us what, you know, V is equal to what IZ, okay? So most definitely we know that I is equal to what V on Z. So the same thing applies over here. We have what VPH on what ZPH, okay? So that will give us what 231, okay, divided by what 10, okay? So it means that this is also what pH, okay? So we have pH is equal to what, when you compute this, you end up with what 23, okay, 23.1 amps, okay, right? So we can now go ahead and calculate what our line current, power factor, power, and what total volt amperes, okay? So now we have A, let's say A or I, okay? We are calculating what the line current, okay? So now for a star connected circuit, okay, for a three-phase star connected, in case you've watched my previous video, you will notice that for three-phase star connected current, okay, the line current is the same as what the phase current, okay? So we have what a certain 23.1 amperes, okay? Now let's move on to the power factor, okay? Now let's see how we calculate the power factor. So for the power factor, you know that power factor, okay, you know that power factor is the same as what cos theta. Okay, so you know that our power factor, which is equal to cos theta, is also the same as what our resistor, okay, the resistor divided by what our impedance, okay? So the resistance of pH, okay, and then we have what divided by what impedance, okay, and then we know that our resistance is already what 8, okay, and then we know pH being calculated as what 10 ohms, okay, so this ohms and then ohms, okay, so the ohms will just cancel out. So we have 10 ohm divided by what 8 ohm on what 10 ohm, and then this will give us what 0.8, okay, so this power factor will be what lagging, okay, so 0.8 lag. Now let's proceed toward finding the power, the main power, okay, so we have I, okay, we are finding what the main power, okay, right. So for the main power for 3-phase, we already know that the power P, okay, or the active power, okay, is equal to what the root of what 3, okay, multiplied by what the VL and then what IL, okay. So this will give us what the root of 3 multiplied by what the voltage. So we had voltage of what 400, okay, 400 volts, okay. So we have 400 volts and then divided by IL, which is what 23.1, okay, 23.1, okay. Note that our power has what a certain power factor, okay, so that's cos theta, so you just multiply that by what 0.8, okay, and then you just compute your value for your power, okay. So when you punch this, you will end up with what 12800, okay, 12800 watts, okay, 12800 watts, okay. Now let's proceed to what the last one. We have to find what the total volt ampere. So it means that we are multiplying a certain voltage to what the current, okay, but in a formula pattern, okay. So for the total volt amperes, that's where we have our what S, okay. So know that S is equal to what the root of 3 VL and then we have what IL, okay, right. So we have what S is equal to the root of, that's the volt amperes, okay, multiplied by what 400, okay, and then we multiply that by what 23.1, okay, 23.1. so our X volt amperes will be equal to what, when you compute all of this, what will you get? That's 1600, okay, 16,000 volt amperes, okay, volt ampere. So this brings us to the end of this question. So let's take a look at the second question, okay. You could notice that this was very straightforward but a bit confusing, okay, right. So let's proceed. This will be much more confusing than our initial question, okay. So now we have to find what certain parameters, but we are given what a balanced delta connected load of what 15 plus J18 ohm impedance, okay, per phase, okay, and then this phase is connected at the end of a 3-phase line as shown in the figure below. So this is the figure, okay. So these are the 3 phases, okay, right. And then the line impedance is what 1 plus J2 ohm, okay. So this is what the connected load, and then this is the line impedance, okay, right. And then we have what the line is supplied from what a 3-phase source with a line to line voltage, okay, line to line voltage of what 207.85 VRMS, okay. So whenever you see VRMS, you notice that we are talking about something relating to what impedance, okay. Now we have to take VAN as reference, okay. So let me introduce us to what the VAN, okay. So now these are what entire 3-phase, okay. So for here we have what we have 1 plus J2 ohm over here, okay, and then we have what 15 plus J18 ohm right here, okay. Now, and then we have a certain what VL, okay, to be 207.85, okay, volts, okay. Now, since we already know these parameters and we have to take what VAN as reference, so for VAN, okay, so this is what we are to calculate, okay. We have to calculate the current in the phase A, okay, that's from the VAN, okay, and then the total complex power supplied from the source, magnitude of the line to line voltage at the load terminal, okay. Now, in order to do this, you have to take what VAN as the reference, okay. So in simplicity, this is the entire what question, and then it's being simplified into this what diagram, okay, right. So you can use a diagram as what reference. Now we have to take what convert, or to use a VAN to convert what a certain parameter, okay. Now, so we have three phases over here, okay, which are in what a delta, a balanced delta connected load, okay. Now we can do one thing, okay. We can just transform what the delta connected load to an equivalent to Y connected what load, okay, resulting in the phase A equivalent circuit, okay, shown in this diagram, okay. So now all we have to do is to just use our solution, okay. So solution will be what our VAN, okay. So we are using the VAN as what reference, okay. So now our VAN will be equal to what our VL, okay, divided by what root 3. So we are converting, okay, or transforming the delta connected to what equivalent to Y, okay. So we have 207, okay, 0.85 divided by what root of what 3, okay, and this will give us what, this is 85, okay, this will give us 120 volts, okay. So from here we can redraw our delta three-phase circuit, okay. So this is how the circuit will now look like, okay. So we have A, okay, these are A points, they move in this direction, okay. Then we have conductance, okay, then we have dots. So in case you remember, you could notice that in case you are dealing with what direct current, okay, you tend to what reduce the circuit. So that's something similar we are doing over here, okay. We are trying to reduce the circuit, okay. So now we have our V1 to be equal to what 120, okay, with an angle of 0 degrees voltage. And then we have what 1 plus J2 ohm, and then we have our what 5 ohm, and then we have plus 6 J ohm, okay. So we've been able to reduce this into a simpler format, okay, right. So let's proceed from there, okay. Now, so from here we can just start calculating our the current in the phase A, okay. The current in this phase, okay, this is our phase A, so the current over here. Then let's proceed from there. So we have what IA to be equal to what 120, and then angle of 0 degrees divided by what 6 plus 8J, okay, or 6 plus J8, okay, and then that will give us what 12 with an angle of what minus 53.13 degrees, okay, and this will be in what amperes. Now we already know this voltage, okay? So, and then we know what this impedance and then this impedance. So all we are doing is just implementing what I is equal to what V on what Z total. So these are 120, okay, 0 degrees, and then divided by what 1 plus what 5, okay. We are just adding, okay. So we have 1 plus 5, that's 6, and then we have what 2 plus 6, okay. So we are adding like terms, okay. So J adding to J, and then the real portion adding to the real portion, imaginary portion adding to the imaginary portion. So that's what J8, okay. So that's how come we got our what 12 with an angle of what minus 53.13 degrees amperes, okay. It's not anything difficult, okay. Now let's move on to B, okay. Move on to B. So for B, we are calculating what the total complex power supplied from the source, okay. We are calculating the total complex power from the source, okay. So now we know that S, okay, is equal to what? So these are some equations we need to what derive, okay. So we have what 3 is equal to VAN, okay. They already calculated VAN, and then multiply by what A, okay. So this is the A already being calculated, and then we have what VAN, okay, right here. So now that will be our what the total complex supply, the total complex power supplied from what the source, okay, right. So let's try calculating that. So we have what 3 multiplied by what VAN, okay, that's what 120 with an angle of what 0 degrees, okay. And then let's proceed. We have what the I which is what 12 with an angle of minus what 53.13, okay, is degrees, okay. So now let's see how we compute that. So when you multiply this one throughout, you end up with what 43, okay, 20 with an angle of what 53.13 degrees, okay. And then you can just convert this into what complex, because we are to find the answer in what complex form, okay, not polar, okay. So you can just use your calculator, okay, to just convert this to what polar form. So when you convert this to polar form, you end up with what 2592, okay, watts, okay. And then we have what this portion to what plus J 3456, okay. That will be our what VAR, because that's volt amperes. That's because S is what has a unit of what VAR, okay, watts. So these are power, and then these are what in total. So let's find out what the magnitude of the line-to-line voltage at the load terminal, okay. We are finding magnitude of the line-to-line voltage at the load terminal. That's quite simple, okay. So we have what C, okay, to be equal to V, okay, V, which is equal to what 120, okay, with an angle of 0 degrees, okay, right. And then we subtract that, okay, from 1. So note that we are calculating what magnitude of the line-to-line voltage at the load terminal. So we are summing everything up, okay. That's the magnitude, okay. So we have 1 plus J2, okay, and then we have what S, okay. We have 12, and then we have what minus 53.13, okay, degrees. Okay, so that's our total what magnitude, okay, at the terminal. Okay, so we have that. Okay, so we have what the 120, okay, the VAN, okay, or okay, so the VAN in what polar form, and then we just multiply that by what IA, okay, and then we subtract that from what VAN. Okay, so we have our impedance. Okay, so this are impedance at what this point. Okay, right, so notice that we are given what the balanced delta connected load at this point, and per phase is connected at the end of the three-phase line. So that's why initially I stated that you should take note of this point. So line as shown in the figure below. So this figure, okay. Now the line impedance, okay, the line impedance is what this, okay, per phase. So that's why we are calculating what the magnitude of the line to line what voltage at the what load terminal. Okay, so you are just subtracting what the line to line what this portion, okay, the line impedance. Okay, we just multiply that by what our VAN, and then we just multiply that by what our IA, and then subtract that from our what V, okay, this V or VAN. Okay, right, that's what it simply means. Okay, that's the magnitude for the what line to line voltage. Now so let's compute this. When you compute this, you end up with what 93, okay, 93.72, okay, and then with an angle of what minus 2.93 degrees, okay, 93 degrees. Now this will just bring us to the end of this video. Okay, so notice that once you subtract what your this VAN, okay, VAN from our line to line what impedance, our line to line impedance, okay, or line impedance, that's when you multiply line impedance by what IA. Okay, so we have what impedance, that's what voltage. So the unit for this would be what amperes, because you'll be left with what only amperes. Okay, because this IA is what this IA asterisk. Okay, IA asterisk, the unit is what amperes. Okay, right, so this brings us to the end of this video. Okay, kindly subscribe to the channel in case this video was very helpful to you. Like the video. In case you have any question bothering you from this tutorial video, just leave them in the comment section and I'll reply to them as soon as possible. Have a lovely day, and I'll see you in the next video. Bye bye.